We cannot magically teleport thousands of tons of steel, life support, and cargo to Mars. Every single gram of material we want to put on another planet requires a massive physical vehicle to push it there. Historically, the aerospace industry has treated rockets like custom-tailored suits. They are bespoke, meticulously crafted, single-mission vehicles. Building them one by one is a slow process that cannot support a growing off-world outpost. That historical limitation is exactly what SpaceX is trying to solve inside this $1 billion manufacturing facility dedicated solely to building Starship. At the top, a traditional rocket build cycle takes months to produce a single craft. Below, a parallel mass manufacturing pipeline provides continuous output. By treating spacecraft like cars on an assembly line, engineers turn out multiple vehicles simultaneously, without waiting for the next launch. The distance to Mars averages 140 million miles. To move meaningful amounts of cargo across that vast void, you need thousands of flights. High-volume manufacturing is an absolute requirement to meet that demand. True space colonization begins on the factory floor. Without industrial mass transit, reaching Mars remains a mathematical impossibility. Pushing these heavy structures off the ground requires an immense amount of raw thrust to break free from Earth's gravity. SpaceX leadership has set an aggressive near-term timeline for all this new hardware. Within a few years, they plan to use these factory-built rockets to send humans back to the moon. The lunar surface offers a harsh, unforgiving environment that is relatively close to home. It serves as a critical milestone to test the hardware. The moon is not the final objective. It acts as a necessary proving ground to ensure the absolute reliability of the mass transit system. Once that lunar capability is thoroughly tested and proven, the entire manufacturing pipeline will pivot its focus to the ultimate planetary goal, a moment of wonder. Shortly after those initial lunar missions are established, the destination becomes the Martian surface. A Martian mission introduces steep new challenges. A trip to the moon takes days. A trip to Mars takes months, requiring vastly more durable hardware and long-term life support. This step-by-step itinerary is designed to systematically stress-test the mass transit model across increasingly distant and hostile environments. Moving humanity to another planet requires thinking beyond a single launch. It requires a massive fleet. The operational goal, according to the vice president of SpaceX, is to send thousands of these starships at a time, coordinating them as a synchronized fleet rather than isolated missions. While the fleet operates on a macro scale, the critical challenge is at the micro level. Every individual ship in that fleet must safely sustain human life for the entire multi-month transit. A historical space capsule holds 4 people. Beside it, a single Starship carries up to 100 passengers. Keeping everyone alive requires strict planning. The ship must recycle precise volumes of breathable air, clean water, and nutritional supplies. For these pioneers, the journey is an intensely communal experience. You are spending months in zero gravity, sharing close quarters with 99 other people. By putting that many humans on a single vehicle, the journey scales up from an isolated scientific expedition to a massive human migration. Ultimately, the output of that $1 billion rocket factory is an industrialized mass transit gateway built to push humanity outward and establish a multiplanetary presence.